Okay, so this video is going to cover something that I think is very important, but your book doesn't talk about explicitly. I'm going to talk about something that's going to hopefully really help you with the problem solving. So, if you watch the density video, I go on at length about different kinds of conversion factors. So I spent some time on these videos talking about how to do conversion factors and how to do converting from one unit to another. But dimensional analysis is much broader than that. We can actually do things that aren't just converting one unit to another. We can do problem solving. So equivalence conversion factors are a ratio that measure one type of unit or one type of measure to another. So things like densities. Densities are an equivalence conversion factor. The density of lead is 11.3 grams per cubic centimeter, right? So this tells me that I can make a conversion factor of 1 cubic centimeter per 11.3 grams, or 11.3 grams per 1 cubic centimeter. Now, these are conversion factors, but they're between different kinds of units. One is a volume and one is a mass. And normally we can't say they're equal. And they're not equal. They're just equivalent under certain conditions. What is the condition under which this conversion factor is applicable and true? Hopefully you said it's when talking about lead, right? Because this is the density for lead. We cannot use this conversion factor for any material. We can't use it for copper and aluminum. We can only use it for lead. So we're going to have lots and lots and lots of conversion factors like this. And in fact, they can be more sort of fleeting and conditional. One I like to use a lot is the idea of a speed. So let's say we are traveling at 0.6 miles per hour, right? So here's how I can use this. This is now, think of this as a conversion factor. I might now pose the question. Let's say I know that we're traveling on an average of 58.6 miles per hour. And I say, oh, okay, we've got 16 more miles to go. How many minutes is it going to take us to get there at this velocity? Well, this is pretty easy. So I'm going to convert from, I'm going to use this velocity directly. I'm going to put miles down here, and I'm going to put hours. So this is, you have to think of this. This is a velocity. It's a link between distance and time. There's no sort of unit conversion I can use to get me from miles to minutes, because you can't relate distance and time like that. But if I have this, if I say under the condition we are traveling at this velocity, I now have a relationship between distance and time. But it's only under this condition. So I'm going to put 58.6 miles per 1 hour, right? And that's great. I can calculate this out, and I actually happen to get an answer of 0.273, which that's great, but that's how long is that in hours? So this only spits out the answer in hours. You may need to combine unit conversions with this. So hours, minutes, 160, right? So now times 60 gives me, well, that's fun. Oh, because it was almost 60 miles an hour. So 16.38, but I only gave two significant figures, so I've got to say 16 minutes. So there we go. So let's talk about something. Let me do another example of a kind of conversion. I have a tank. So this is going to be, I've got a tank that is 1,500 liters, okay? And I'm going to fill it up with a hose. So I'm filling this up with a hose, and I do a test. I take a 5-gallon bucket, and I put the hose, because I want to figure out how long this is going to take me. I put the hose in here, and I fill it up, and it fills up in 23 seconds. Let's do 23 seconds on the dot, just so I have enough significant figures. Also, since I'm making these numbers up as I go, let's do that. Liters and then 23.0 liters, or 23.0 seconds. So a 5-gallon bucket, and it's 5 gallons, 5.00 gallons, in 23 seconds. I want to know how many hours it's going to take this tank to fill up if I just put the hose in there. So here's how we do this. Now I'm going to talk about this in the abstract first. So what we have is the way to think about a problem like this, I think the best way to think about this is to say, okay, what kind of unit do I have? I'm starting with, if you remember the problem, I'm starting with a volume, right? I've got a volume, right? Because I have 1,500 liters, and I want to know how many hours it's going to take to fill it up. So I'm trying to get over to time, right? Now, if you look at a problem in this way, you say, I'm trying to go from volume, and your answer is, I'm trying to go from volume to volume, well, then all you need are unit conversions. You don't need anything else. That's just a unit conversion problem. However, if you're going from volume to time, somewhere in the problem, you have to be given the information or have to have access to the information. Well, what is my relationship between volume and time? I need a conversion factor that relates volume and time. And my volume and time relationship is given here in my test with the bucket. So if you think about that, that is a ratio of 5 gallons every 23 seconds, right? 5 gallons every 23 seconds. So that's my conversion factor. So I think before you start, a lot of times it's helpful to try and map these things out. So you can say, okay, I'm going to go from here, I'm going to go from volume to time using this conversion factor. Well, you can even figure out from the beginning which way you need the conversion factor to go. I've got volume up here in the numerator, right? I need to cancel it out. So my volume is going to have to be in the denominator. So I need to flip this conversion factor upside down. So it's going to end up being 23 seconds over 5 gallons. Now, here's the thing, though. This is only going to cancel out gallons. So I've got volume in liters. I need to convert it to gallons first, and then I can use my conversion factor to go to seconds. See over here, right? And this is where this is going to go. And then my seconds, I can go to minutes to hours. You can map this out this way. But what's key is a lot of times the big keystone in the problem is thinking about how I'm going to get from one kind of a unit to another. So in this case, how do I get from volume to time? Oh, this relationship between seconds and gallons. That's how I do it. So let's actually put this into practice. So as I said, we're going to need to go to from liters to gallons. So I need a conversion factor. So this is just a regular old unit conversion. I look in my book, I have to flip the pages a little bit, and I find 1 liter is 0.265 gallons, right? And now I can actually use this conversion factor. It's actually right in a very awkward place. 23.0 seconds to 5 gallons. Cancel. And now we've successfully converted to seconds. And now all I have to do is go seconds to minutes. Right? And then I have to do, one down here. I'm just going to continue down here. Minutes. Nope. Yeah, seconds to minutes, and then minutes to hours, 60 and 1. Oops. There we go. And so I take 1,500 times 0.265 times 23 divided by 5 divided by 60 divided by 60. And so I get 0.508 hours. It's pretty fast, faster than I would have thought, actually. A little over half an hour. Okay, I hope that helps. In class, we are going to do a lot more practice on this. So, and I'll dig up some more problems for you guys to do. So hopefully, you're getting the sense of how to do these kind of problems. This is going to repeat a lot during the quarter. So we'll do more practice.